So in the last class, we discussed what is a language model and how we can use a language model in terms of, how we can use a language model to retrieve documents, or how we can use language model as a retrieval tool. So in general, a language model was a model which was assigning a probability to a sequence of words by means of probability distribution. So we have discussed this kind of a situation, which is considered mostly from the natural language processing point of view. You have any question? Someone? No, Amarjit, can you please? Yeah, thanks a lot. So, in order to use the language model for retrieval, what we have done is we have considered a generative model, or we replicate the query generation procedure from the relevant documents as the way to address or to be used as the tool for retrieving a document given a query. Informally, how we can use the language model for retrieval? So basically, if we have a document D in mind, if we want to retrieve this document, what will we be doing? Essentially, we will be, if this is in my mind, so I have some vague idea about the terms that are there in the document. So a good way to select this document at the top rank using some searching mechanism is to consider some TIs which are belonging into the document as the query term. As the query terms. Essentially I should be writing small q, right? So here, for this language model, we will be doing the same thing. That is, we will be considering, given a probability distribution, how likely the query will be generated from this probability distribution. Again, our underlying task is, given a query, select a set of documents which are relevant to the query, isn't it? This is our target. So given if the collection C is containing, say, 1 million document, our target is to select only those documents which are relevant to the query. Instead, what we'll be doing is, for each document in the collection, we will be considering, so basically for each document in the collection, we will be considering its probability distribution. So essentially, there will be 1 million number of probability distributions associated with each of the documents in the collection, and for each of the and again for each of the probability distribution, we will be computing the probability of generation of the query from that probability distribution. So essentially, given a 1 million document collection, theoretically what we'll be having is, we'll be having 1 million probabilities. Now we understand that given a small query, say if the query is say Q1, Q2, Q3, that is having 3 query terms, then most of the documents in this 1 million document collection set will be irrelevant or non-relevant to the query. Most of the cases, it's, you can, I hope you can understand that. Considering the World Wide Web, there are, trillions of documents, actually more than that. And given a query, given a small, given a say 2-3 term query or more, only a very few number of documents are actually relevant to the query, isn't it? Now, considering that, theoretically, this generation, this probability will be computed for all the 1 million documents. But as we have discussed, we can only consider those documents, consider only those documents which contains the query terms. Only those say DI that contains the query term. So basically, so this notation is a little bit very broadly it's written. So this is basically indicating I'll be considering only those documents containing the query terms. How we can do that? We have already discussed using the inverted index. So given the query Q1, Q2, say Q3, three-term query, we will be basically again we will be having three posting lists, PL1, PL2, PL3, sorry, PL2 and PL3. And instead of considering all 1 million documents, we'll be considering only these documents. We can consider a union, we can consider an intersection. That is, we have already discussed what to choose. And we can then, so basically for each of them, we will be having again another probability distribution. Basically we are restricting, we are starting with the collection containing 1 million. Then we are selecting a very few number of documents from them. And we are only considering this probability of generation of the query term from these few documents rather than considering all the documents in the collection. So by this, basically, we will be using the language model for retrieval. So the idea is to consider, so first of all, we will be building a probabilistic language model MD for each of the document D. We'll be also again considering a probabilistic language model for the query. And then we'll be ranking the documents based on the probability of document model generating the query. So now what we are doing is we are considering a probability distribution PD of D, and we are checking or we are computing the chance or the probability of generation of the query from this probability distribution. So theoretically, mathematically, we can write it like this: probability of generation of the query language model given the document language model. Now, easily we can understand that the query, in most of the cases, the query will be smaller in size than the document size. So we can simply understand from our point of view of web search. So in a web search, the web documents may be of having approximately 100 or 1000 size, and approximately the query size will be same, I don't know, maybe 3 to 5 or maybe less than that, or not. It's mostly it will be less than 10 in most of the cases. That is, less than 10 number of terms will be there in the query. That in document there will be more number of terms. So that's why it is actually doable. So from this probability distribution of document, how likely that this probability distribution will be generated. So as we have said, instead of considering this, we will be denoting this as Q given MD, or sometimes, actually most of the cases, we will be considering it as Q given D, or sometimes we will be referring to it as a capital D. So Q given the document, which will be specifying the language model associated with the document. So essentially, there are three steps in using the language model for retrieval. First, we need to construct the language model, associated with each of the document of the collection. Then given the query, we need to compute the generation probability of the query from each of the DIs in the collection. So each of the DIs is basically we have their associated language model which we already have generated. So second step is basically computing this, and then the final step is basically ranking the documents based on the probability in decreasing order. Now, I hope you can understand that these two are basically to be performed during retrieval, because after given, after the query is submitted to the system, then only we can perform this computation, right? So considering that this is needed to be performed, these two steps are needed to be performed during the retrieval when we are typing in the query in the Google, for example. At that moment, we need to first compute the generation probability of the query from the documents, and then we need to rank them. And I guess you can understand that this step, construction of the language model associated with each of the documents in the collection, should be performed during the indexing time. So while indexing, while creating the inverted index, we will be basically constructing the language model. Now, how we'll be doing that? I hope it will be clear by the end of today's class. Now, the first step, as we have said, is construction of the language model. So there are multiple different types of language models. For example, unigram, bigram, trigram, or more than trigram, where more than n equals to 3 n-grams. We have discussed in the last class that sometimes it is easier to consider unigram plus bigram, but we will be considering the unigram language model in order to represent the document as a language model. So again, language model assigns a probability to a sequence of words by means of probability distribution. Now here in IR, we understood that the sequence is not actually important. So sequence, as we are considering just a bag of words concept, sequence is not actually important. So given a query, let's say the query is say Indian sorry Indian Institute of Science and Science Institute of India. I mean, India and Indian are actually different, but if we consider, if we just consider, say, India Institute of Science and Science Institute of India, so essentially they will be considered as the same. There are problems with that, as we have discussed. Let's say the query is, say, Alice is, so they will be considered as same. So the problem is basically, let's say the query is Alice is faster than Bob. Let's keep everything in small. Bob. This and Bob is faster than Alice, both of them will be considered as the same. This is actually a problem because the sequence of words is not actually considered in information retrieval. So, in order to estimate or in order to construct a language model, we can use any sequence of text or any chunk of text, you can say, because here in information retrieval we don't need the sequence information. So any span of text can be considered to estimate a language model. Now note that the language model that we have discussed in the natural language processing course, there the sequence was actually important. So using that sequence, we can actually predict the next word. So given the sentence like say United States of, and what will be the next word? So this kind of a statement can be actually completed using the sequence information, which is important in natural language processing. But here, as we are considering a bag of word model, this is not actually the case for IR. So in IR, in order to estimate the language model, we just need a text, a chunk of text. Not necessarily we will be needing the sequence. But note that for positional indexing and for phrase search using positional indexing, we will be needing the sequence as well. But in general, there is no need to consider the sequence. Now, in order to estimate a language model, we can consider any span of text. It can be a sentence, maybe containing approximately say 10 words. It can be a document containing say approximately 100 or say 1000 or maybe 10,000 words. A query may be approximately containing say from 3 to 10 words. Even less number of words is also possible. So this is just the general range. For a corpus collection of collection of documents, it can be say approximately say 1 million or more than that. So these are the number of unique terms, unique words. For the entire web, I hope you can understand, actually realize it will be a huge number. It will be much greater than 1 million number of documents. It will not be actually much, but it will be much greater. Greater than 1 million number of words. So again, recapping, given any span of text, we can generate a language model out of it. And in IR, for all of this, we'll be basically considering the ARN model that we have discussed earlier in the last class. So it's just an ARN containing different colored balls. So there is no actually order, and if I draw a ball out of this ARN, there is actually no sequence or order that are being maintained. So it's just a dump of words. In language model for information retrieval, we'll be actually considering the same thing. So basically, if we consider this ARN as the document, we'll be basically computing the generation probability of the word of the query words from this ARN or from this document. Now this ARN can be a document. In that case, it will be referred to as document language model. It can be a query. In that case, which will be considered as query language model. Or if it is the ARN is basically the dump of all the words in the collection, we'll be considering it as the collection language model. Mostly these two will be used for retrieval very often, and the query language model will hardly be used, but still to make things, to define things in the same way, we can actually say a document can have an associated language model with it as well. So given a language model, we can actually assign a probability to any span of text. As I said, if the document is basically, if it is a document, there are words, we can actually assign the probability of generation of any query or any span of text, like say this. What is the generation probability of this span of text from this document? That is, how likely if I make three word drawing from this urn, how likely that I'll be, so let's say this is A, this is B, and this is C, three terms. If I make three drawing of words from this urn or from this document, how likely that I'll be getting A, B, and C in no particular order. That is basically the probability of generation of the query given the document. Or as I said, it can also be written as MD, or we can refer it to as Q given D simply. Any question up to this? This is very important concept that should be clear. All right. So again, this is, we have already discussed that if we consider this urn as a document, the way we will be using the language model for retrieval is the generation probability of the query terms from the document. Now, as we have discussed, there are multiple ways of estimating this document language model. One is unigram, bigram, or anything else. So as we have said, in the information retrieval, we generally consider unigram language model. That is, in unigram language model, individual words are considered as the individual tokens. So in that case, it is basically the tokenization of the entire text with space, you may say. So in that case, as I have discussed in the last class, if there is a term like Hong and Kong, they will be considered as separate tokens, or separate balls will be associated with the term Hong and with the term Kong in this urn of the document. Okay. So in that case, as we have discussed, the generation probability of a sequence or a span of text can be replicated by using the same concept as the sequence and as a sequence of ball generation or ball drawing with replacement. Note that this with replacement is an important concept here. So basically, as there is no ordering in information retrieval as such we are using, so that's why if the query is, as I said, if it is Alice is faster than Bob, then basically the words are basically Alice is faster than Bob. So basically there are 5 words. Okay. And I'm online, right?
Yes.
Yeah, okay. Thanks a lot. Mm, so, yeah. So basically, there are 5 words, right? So considering these 5 words, they will be basically considered as different balls, different colored balls. Note that every ball will be associated with a different color. Now, as I have discussed the problem, A is faster than B and B is faster than A will be considered as the same. That is why, I mean, that is because we are not actually considering the order in information retrieval. So basically, the generation probability will be computed with replacement. So if I make a draw, if I want to get the sequence of words, essentially from the NLP point of view, the first drawing should be red, then yellow, then red, then blue. But from IR's perspective, it is basically if I make 4 draws, 4 ball drawing, what is the chance that I'll be getting 2 reds, 1 yellow, and 1 blue in no particular order. This is the most important difference between the NLP and IR's point of view of language model in no particular order. Okay, all right. So Unigram language model, as we have discussed, Unigram because it estimates it actually considers every word as independent from each other, and other language models are also applicable for different purposes. Generally, for information retrieval, we will be considering the Unigram language model. That is, we will be considering the individual words as individual balls. So there will be no phrase consideration as such in the Unigram language model. And this is the important thing that should be highlighted here, that this Unigram language model generation would be would be performed during the indexing. Now let's spend some time on this. So during indexing, earlier during vector space model or VM25, what we have considered is basically uh, to perform the BM25 retrieval or BM25 scoring or vector space scoring, we talked about some term weighting, isn't it? So these term weights are actually stored during indexing. So given a document, when the document is being indexed, what we are doing is we are essentially storing the term, say T1, along with the weight of the term, then T2, then weight of the term T2, and so on. Right? So earlier in vector space model or BM25 retrieval model, we have used these weights in order to perform the document scoring. Note that this is already been done during indexing. So again, in order to estimate or in order to get the corresponding language model associated with the document, we can actually, so what is, what is basically this? It is basically the probability of all the words TIs given the document for all TIs in the document, such that number one condition is probability all the TI given D should be greater or equals to 0 and less than equals to 1. And second condition is the summation of TIs belonging to D, the probability of TI given D should be, I hope you can say, 1. So, a language model associated with a document is basically this. So, basically, a document is consisting of terms T1, T2 up to say Tm. So, the language model is basically some weights or some probability. This probability is associated with the words from that document. So, in order to do this Turing indexing, what we need to do is we need to store this all these PTIs. So for all these terms, we need to store all these PIs in the inverted index. In inverted index, we need to store them. All right. So how we can actually estimate this? As I have said, this is the document language model, and we need to compute this. So how we can compute this? So again, repeating, a document is essentially a set of terms. So the language model associated with the document is basically a set of weights or a set of probabilities. So how to compute these probabilities? How to compute these probabilities for all the terms, which will be basically forming the language model associated with the document.